you're here for Istio 101, as is printed on the paper agenda, you're in luck. There's a better talk called Distributed Microservices, Metrics and Tracing instead. The Istio talk was yesterday. I'm sorry that you missed it. This talk will be using Istio, though, and open census, but it's going to be focused on metrics and tracing. So let's get started. So my name is Sandeep. I'm a developer advocate at Google. I'm from the San Francisco office. I flew all the way here to talk about metrics and tracing because, I don't know, they gave me a trip to Hamburg, which was great. So when you think about a typical app that you might write, you might have like a 3-tier app. You have a front-end logic, some business logic, and a database. And typically, you would write a monolith to do this, right? Why would you ever use microservices? Makes no sense. Makes it like a million times harder to do something simple like this. With a monolith, you have everything in one programming language. You have everything in one place. You have everything in one, maybe like one file. Hopefully not. Hopefully you've distributed that out a little bit. But it's a lot easier to understand and figure out what's going on and then debug it and to make sure that it's all working correctly. The problem comes when you start expanding the scope of your project, right? In this case, you have different parts. You might want to scale them separately. You might want to write each part in a different language. You might want to put different security policies in different parts, right? And so it becomes a lot easier to do something like service-oriented architecture, SOA, right? The word that hurts everyone's soul. But it makes sense, right? Each one of these is its own service with its own policies, its own SLAs, its own whatever, its own team, things like that. And for the most part, this works really well. They're still pretty monolithic, right? You can still, they're very isolated from each other. They're not really super interdependent. They all work together, but you only have like 5 or 6 of these like services. So you can still use the traditional tools that we use in the monolith for like an SOA architecture. But then when we think about microservices, it becomes like impossible to even like look at this graph and know what's going on, right? I copy-pasted the other one like 6 times. That's what I did. It was very easy to make microservices. Just copy-paste, right? But the problem is, you as an individual, maybe you're working on this, what? That is a hard screen. On this microservice right here. How do you know where in the world your traffic even originated from? How do you know what is causing your service to break? Why is the downstream service breaking only sometimes, even though you're sending the same traffic to them? It becomes really complicated really, really quickly. And while the code in each of these might be yours, you might own it, you might understand it really well, you don't understand the network effects of the whole system, right? It becomes really hard. So why do we even want to do microservices? Because microservices, no matter what anyone tells you, add network and infrastructure complexity to your system, right? Before you had one thing, you deployed it, and it was done. If you wanted more of it, you just deployed more of it, right? And you put a load balancer, and then you're done. OK, cool. But when you have microservices, all of a sudden you have like thousands of different services, thousands of different policies, thousands of different this thing, that thing, deployment strategies. This one has to be deployed before that one. Who knows? It's really complex. But what they do and why we love them so much is they remove code complexity from your system, right? Instead of having a 10 million line Java application that no one understands, and when that one person leaves the company, you're like, oh shit, let's rewrite it, because it's easier, right? Instead of that, you have these like small little pieces of individually running services that you can rewrite in like a month. And so if you need to, let's say, move from Python to Go, you can do that for just that one part that needs to be rewritten, right? Instead of having to refactor this whole giant thing that no one understands. So that's why we love microservices, because they make code complexity a lot lower. And the really nice thing is that infrastructure can be automated, while at least as far as I know, code can't, right? If code could be automated, we'd all be out of jobs, maybe one day. But infrastructure can be automated, especially on the cloud with APIs, right? So you have things like Kubernetes, where you can spin up infrastructure basically on demand. Versus code, you had to sit there and write that in your editor, right? So let's use that to our advantage. Let's use tools to basically simplify that network and infrastructure complexity. And this is where microservices really, really make sense. microservices do not make sense unless you use these tools. Then you just have the worst of both worlds. You have the worst in terms of like infrastructure complexity, and you have the worst in terms of like you have no tools to like even figure out what's going on, right? You're basically throwing away everything that you learned from monolith, and then you're taking none of the advantages of a microservice. So you have to use tools, otherwise you're just going to shoot yourself in the foot. So the one thing I do want to talk about in depth about what tools we want to use are for distributed tracing and distributed metrics. So in a monolith, it's pretty easy to do tracing, right? You open up VS Code, you click breakpoint or whatever, and you see what happens. You don't really have to care too much about tracing because it's just one function call, one function call. You can read the whole stack, right? You can just like look at it in memory. You don't have to think about it. But when it comes to a distributed service, you can't do that anymore. Because you might have service A call service B, call service C, and service A sees 100 milliseconds latency when it calls service B. And that's all it sees, right? It doesn't really understand that service B is actually calling service C with 90 milliseconds latency. So service B is only adding 10 milliseconds, but service A thinks service B is taking the full 100 milliseconds, right? And it becomes even more complicated than that, because you might have a single request coming into your front end that gets fanned out to multiple microservices, that fan back into a single microservice, right? So in this case, we have our analytics front-end server talking to 3 different systems, which makes complete sense, and they all talk to the same database. And the database talks to the underlying storage platform, right? Now, that underlying storage platform just sees a bunch of requests coming in from the database. It doesn't really understand that that was one original request that split into 3, that split back into 1, right? It has no context. And so without context, it becomes a lot harder to understand what's going on and a lot harder to debug and find hotspots and things like that. Now, fortunately, we have ways of dealing with this, right? How many people have seen something like this? Yeah. If you ever open up Chrome and look at the network tab, you've probably seen something like this. It's called a waterfall chart. This is Zipkin, which is one of the open source distributed tracing programs. And you can see that basically it's pretty obvious in a visual sense to figure out what's going on, right? You have a call going on here, and then you have a bunch of asynchronous calls to that call, but these are all in series, right? So this one goes to go first, and then this one, and then this one, and then this does a few calls in asynchronously, right? Or in parallel. So we know that if we can make this shorter, then the whole thing becomes shorter. But if we can make this shorter, it really doesn't really affect the overall performance because this call is going to be longer anyway, right? I have no idea what any of this is. I just found a screenshot on the internet. And then, I mean, there's a lot of tools like this. So this is Google Stack Driver Tracing. And again, it looks very similar, right? Again, we can see that this call goes first, and then the call to spanner, and then these go in parallel. So it doesn't really matter if we get top picks becomes faster, because get articles is the bottleneck here. So what this lets us do is find these hotspots and optimize things that should be optimized, right? We shouldn't waste our time optimizing get top picks. We should be instead wasting our time optimizing get articles, because everything we do is a waste of time at the end of the day. So that's cool. That's cool. How do you enable that in your applications? So here's the problem. When you have microservices, you might have like 20 microservices in this one call, right? When the first request comes in, you have to create trace IDs. So trace IDs are how you basically trace this throughout your entire system. Now, you shouldn't create them for every single request, because then you'll overwhelm your tracing system, right? So you have to do sampling and make sure they're only put on, every 10th request or every 100th request, something like that. Now you have to put these trace IDs into the request itself, usually in something like the HTTP headers or whatever. Now, every service in that 20 services chain needs to take those traces and then report the data back to some sort of centralized collecting system, right? Now, here's a really important part. Every single service needs to forward those headers on. If any one of those services in that chain forgets to do this, you've all of a sudden lost context, right? So if the 10th one in the chain just like forgets to send the trace headers, then the other 10 don't understand where the request came from, right? So every single service in your microservices platform has to forward these trace headers, which means that it's not just your team who has to do this. It's every team in your company or every team in your project that needs to make sure they're doing this, right? And of course, you need to be able to query these traces and do like data processing and understand what's going on, right? Just having the data is not good enough. You have to be able to understand it. And then we have distributed stats. So you can't see this, but it's not really important. This is like the default Stackdriver monitoring dashboard for Google Kubernetes engine. And you might think, wow, cool, it gives you a bunch of information. But what does it actually give you? It gives you things like CPU usage, disk I/O, network traffic, memory usage. Now, these are useful statistics. And you can get these for like per pod, you can get these per service. It's actually pretty cool. But the problem is these metrics aren't what you want at the end of the day. What is CPU but a proxy for latency, right? What is disk I/O but a proxy for latency? Damn, I don't think of anything else except latency. Or like memory or something like that, right? All these things are just proxies for what your business actually cares about. You care about things like P99 performance. You care about things like how big is the average incoming request? How big is XYZ or whatever, right? You care about these things that actually matter to your business, not these stats. And unfortunately, we tend to use things like this because it's all we have, right? Especially in a distributed system where you're trying to see an aggregate picture of like all your microservices, and all you really can see is like disk I/O, memory, CPU usage, and things like that. So again, just like distributed metrics, what we want to do is be able to collect meaningful statistics that actually mean something to our application, and then send these stats to a collector, and then I'll query and search these stats. And again, we want the same trace ID should be tied to these stats as well, right? A certain request might trigger a certain set of metrics to be collected. We want to know why that triggered, what upstream services triggered those metrics versus different thing, right? It's a little confusing, but if you just have stats, it's kind of out of context. Again, you need that context of like what the request was, what the upstream and downstream things are doing to have it really useful. So here's a really, really good news. In fact, there's a bunch of people in the expo hall right now that will sell you a solution that will solve this problem. In fact, there's so many of them. Like Datadog, I know those folks are in the expo hall right now. Again, we have all these things, but it becomes overwhelming. And the problem is your team might really, really want to use Dynatrace, right? But then the other team says, no, I'm going to use like open source Prometheus. And you're like, no, we got to fight out because we have to use a centralized system. That's the whole point. We have to use one, right? And so it becomes hard. And once you kind of pick one, you're locked in forever because all your historical data is there. And it becomes kind of difficult to move out. So let's talk about two things that hopefully can solve this, OpenCensus and Istio. So show of hands, how many people have heard of Istio? I think most people, okay. And then keep your hands up, or another people, raise your hands if you've heard of OpenCensus. Yes, okay, that's what I thought. So basically, these are standards that try to standardize that problem. And of course, as we all know, with standards, everyone has seen this comic, so I don't even have to explain it. I'm just going to keep going. So what did they actually try to do? Basically, the goal of OpenCensus and, in a lesser degree, Istio is to kind of provide these metrics and tracing and stats and all this stuff for your operations teams, right? For people who really care about the health of the cluster, for the health of the services, while getting out of the way of developers. And let's see a demo to actually understand how that works. So just a quick Istio thing. If you weren't at the talk yesterday, Istio can do a bunch of stuff. Request routing, load balancing, auth, failure management, blah, 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 blah. I have a full video talk, code on GitHub, all this kind of stuff. You can go there. This link will be at the very end, too, so don't worry about taking a picture. Everyone's taking a picture. It's fine. You can take a picture. I won't be going into any of this stuff for Istio. I will only be talking about metrics. OK, so let's take a look at how Istio and then OpenCensus can actually help us with these tasks, right? So if you don't know how Istio runs, it's basically a sidecar proxy that takes all the outgoing and incoming traffic from your container and then proxies it, right? Because it's able to read all of these network calls in and out of your code, it's able to automatically understand what's going on, right? And so you don't have to actually do anything. It'll just take all these stats and send them to the centralized collector for you automatically. So this is really nice. That means all of your network RPCs, all of your network calls, all this kind of stuff automatically gets a lot of stats, metrics, tracing, all this kind of stuff out of the box for free. So that's cool. But what happens inside of your code? So let's say your code, before it does that network call, it calls 3 functions. The second function calls 2 functions in parallel. Now, we had to figure out which one of these 3 functions to optimize. And from this picture, obviously function 3 is taking the longest amount of time, right? So maybe that's a good target. But with just Istio, we're not going to be able to see any of this. We're just going to know that service B took that much time, right? So what OpenCensus does is it lets us actually put tracing that comes in from Istio into our code, and then send it to the same collector downstream. OK, so that's enough of me talking. Let's actually look at a demo. So I have a Kubernetes cluster created in the Frankfurt data center. How many people have used GKE before? A few people, like half. OK, cool. It's super easy. You just click create cluster, and it creates. So let's say I have E-A-R. OK, so what I want to do first is install Istio. And how you install Istio is you kubectl apply a giant YAML file. See? Let's see what happens. And it'll do its thing. Look at that. It's beautiful. No one really knows what's going on when you install Istio. I'm just kidding. Basically, what it's doing is it's installing the control plane. And I'm also installing a bunch of the monitoring and tracing backends that are open source, like Prometheus, Grafana, Zipkin. Oh, that is. Huh. That's not supposed to happen. OK. Working yesterday. That's what I always tell myself. Let's see. Huh. OK. Let's see. It's very interesting. So Istio is definitely not running yet. Why did it fail? Let's try it one more time. Do. Every time I give this demo, the last 2 times, it's always failed on stage, and I go off, and then it just starts working, and it's like, it hates me. It's a service mess. That's a really good, I like that. Let's see what happens. And now it's working. Woo, look at that. See, I just had a, OK. OK, here we go. So now we're creating Prometheus and Jaeger for tracing, things like that. So what Istio is going to do is it's going to live in its own namespace. So once you deploy it, we don't really have to care about it anymore as a developer. And then this is a little small to read, so I'm going to make it a little bigger. The one thing that I did here is I'm going to scroll it up a little bit. I did this thing called kubectl label namespace, and it's put Istio injection equals enabled. So we'll see how that works in a second. So that's kind of like all I have to do. And now the default namespace, anything I launch in there will get Istio automatically. OK, so do that. OK, so let's see if the kubectl get pods. Let's say no resource was found because it's all running in the Istio namespace. OK, cool. So let's look at our code real fast. So I wrote it first in Node.js because I'm a Node developer. And it was like 10 lines of code, very simple. Basically, it will ping. Again, no one can see that. Make it a little bigger. Ooh, too big. So it'll ping a downstream. And then it'll basically get what are the responses, concatenate it in like a timestamp, and then send it back out, right? So basically, I can daisy chain an infinite number of these services together to create a fake microservices stack. Super cool. The problem is for Istio to work, you have to forward the trace headers. And so I'm using the B3 headers, which is like what Zipkin uses. And so I have to actually forward all these headers manually. And that kind of sucks as a developer. If I forget to do this, Istio distributed tracing won't work. So let's see how OpenCensus can help with that. So I had to rewrite it in Go because when I originally wrote this, there was no Node.js support. There is now. And my 10 lines of Node.js turned into 45 lines of Go, because that's how Go works. So at the end of the day, basically, all I have to do is add this OC HTTP handler into my listen and serve function. And so this is basically a plugin or a plugin for the Go HTTP server. That when you add it in, it actually automatically adds distributed tracing and metrics to my HTTP server without me having to really do anything. And so in my handle root function, I do the same thing I do in Node.js. A lot of context. I don't know what context really is. I mean, okay. I do now after doing this, but before I did not know. It's cool stuff. I wish we had that in Node, but we don't. And then a lot of error handling. Later, we have our code. So let's deploy this. Deploy stuff. All right. Cool. OK, so let's wait for this stuff to spin up. Yeah, I love stuff. It's a great word. So you might notice here it's saying init 0 out of 1 and ready 0 out of 2. In my YAML declarations, I only declared one container. But what Istio actually did was detect that I'm deploying this into the default namespace and inject itself into my pod. So I didn't have to even understand what Istio is as a developer to get the benefits that it is going to give me. So let's do it again. Hopefully it's all running. Nope, it's not. Now it's pod initializing. So obviously it's a fresh cluster, so I need to pull all the containers down. Let's give it a few seconds. My ingress has already spun up, which is great. So let's take this. OK, so you can see here the front end, middleware is saying a not OK 503. It's not ready yet. So again, let's do make it stuff. Cool, everything's running. And now if I hit refresh, it should all work. Cool. So it's pretty simple, right? The front end talks to the middleware, talks to the back end. I have 3 deployments. They're all running the same code, and one's pointing to one, another one's pointing to the end, and then the back end's pointing to nothing. So you can see, obviously, the back end takes almost no time, and then obviously the time keeps going up because it's encapsulating the response of the downstream, right? So with just that, so basically no custom code with Istio and a little bit of OpenCensus to just do the forwarding automatically, we can actually get traces for the network. So here's Jaeger. Remember, I launched this into my cluster. And so if I say find traces, I can see this. So I get this nice little reverse pyramid where the front end talks to the middleware, talks to the back end. Now that's really interesting. At least I can see now how long each service is taking in our call stack, right? And this is kind of a trivial example where it's just like 1, 1, 1, up, up, up. So it's actually the correct pattern that we're expecting. But I don't really understand what's going on inside of those services, right? What's going on inside middleware? What's going on inside front end? What is taking the most amount of time? Obviously, there's nothing in there, so nothing's taking time. But if I was actually writing a real service, I really don't have visibility into what's going on inside. So that's where OpenCensus can really help solve that problem. So let's go to our second Go code. So it's the same program. You might notice here that I'm basically like registering Prometheus and Jaeger as like the importer and exporter. So typically what would happen is whoever is setting up my backend system would just give me like a little package that I would import in that would do this setup for me as a developer, this little init function. And it's getting this Jaeger endpoint and things like that from Kubernetes config maps, which is really easy. OK, so again, we set the default transport to that OC HTTP transport, which means that it'll do all that automatic stuff for us. OK, now what I'm going to do now is I needed a function that took a lot of CPU time, but was really easy for me to write because I'm not a good programmer. and recursive Fibonacci fit that bill perfectly. So what I'm going to do is basically count how many times this function is called, right? Now, in a realistic situation, you might want to count how many videos are uploaded to your service, how many chat messages your chatbot is processing per day, whatever, right? And so you can get these custom metrics, and you can have like count aggregations, mean aggregations, all these kind of different type of aggregations for your metrics. So this is a count, so it's just going to count how many times this function was called. And so again, with Go, we have to do all this bunch of error stuff, which is, who has time for that? And then this is just for this demo. I'm going to set the default sampler rate to always sample. Obviously, in a realistic situation, you don't want to sample everything because it's going to create an overhead for your code. Okay, so again, all we do is put that OCHTTP handler in there. And now what I'm going to do is in our handle root function, what we're going to do is basically get the context and then pass it to all the child functions that are being called, right? And so from talking to my friends who write Go, this is the correct way of doing it. You pass context around. The context has a context of what's going on, right? Makes sense. So basically, we're going to call trace.startSpan. And so that's going to create a span. And so we're going to call that span fibspan. And then we're going to call our function, which is odd or even. I'm going to create a random Fibonacci number and then test if it's odd or even. Like I said, ran out of ideas. And then end that span. And so inside of our odd or even function, because we're getting in the child context from this trace.startSpan, we're setting it into our odd or even function, which means that we can now call the Fibonacci calculation here and then make another child span. And then also, because again, ran out of ideas, we're going to just sleep for 0.3 seconds and then call that the sleep span, right? And so we can actually give these spans names, like sleep and Fibonacci calculation and all these kind of cool things. And then every time we call fib, we're going to run stats.record and basically add 1 to the count. OK, so it's pretty simple stuff. And the really nice thing is the stats and the span, it doesn't really care what downstream you're using, right? So we saw here that we have all these different vendors that we can talk to. And the really nice thing about OpenCensus is your code changes 0% as long as there's a plugin for one of these downstream vendors. And I know most of these people are working on support for things like OpenCensus and Istio. So it means that your code doesn't have to change, but you can change vendors a lot easier. So instead of being locked in, you have a choice depending on the benefits and features that they provide, which is really cool. OK, cool. So let's deploy this new code. Oop. Doop-a-doop-a-doop. OK. OK, so this last one is still initializing. Interesting. Let's wait for that to finish. Weird. Somehow it's not cached. I'm also running a 4-node cluster because Istio is so big. OK, another thing, while we're waiting for that to come up, please do not use either OpenCensus or Istio in production, OK? Just don't do it, OK? Promise. Everyone promises? OK, cool. If we remember, when Kubernetes 1.0 came out, sure, we supported it on GKE, but do you remember how many features were missing from Kubernetes 1.0? Like stateful sets, not there. RBAC, what's RBAC? CRDs, CR please. Like, what were these things? They weren't there, right? We're on Kubernetes 1.10 now, and now people are starting to actually use it. Istio is still on 0.8. It literally changed the full API from 0.6 to 0.8, which is why my demo is still on 0.6. I was desperately trying to update it last night. That did not work. So give it some time. It's going to get there, and we will all be happy. So, OK, so I'm assuming it's going to get it's ready now. OK, cool. So now if we go back here, hit refresh, obviously it's all updated. And you might notice some more stuff like true and a number. Again, that is that Fibonacci number odd or even, yes or no, true or false, right? So if I hit refresh a few times, you can see like this one is false. And it does take a little bit more time. Not much more time, but it does take a little bit more time. Obviously, the network is the bottleneck here. Can't really do anything about that. So let's go back to Jaeger. and then look at some of these new traces. So find trace. So now we have 20 spans. And so now you can actually see inside of those functions, right? So it's both Istio and OpenSenses reporting the same trace IDs to the same downstream collector, which means that everything gets put into one big picture, right? So in our backend, we can see that the Fibonacci odd are even, our Fibonacci calculation are asleep, and the same thing with the front end and the back end and all this stuff. Okay, so we also get a lot of interesting things with Istio. Because it's doing all the network stuff for us automatically, it's reporting all this to Prometheus, which is being graphed into Grafana. And so this is the default Istio dashboard. If you ever used Istio before, you know how this works. So you can see things like your request volume, your global success rate, things like that, and a bunch of other information. So these are things that really matter to your application. I still don't have enough traffic, apparently. OK, so this is the Sandeep patented Ddos method. Click refresh a bunch of times. Who needs bench or whatever? No one needs that stuff. So you can see my ops went up a little bit, spiked. I'm not able to DDoS my service, unfortunately. Usually these are full of things. I don't know why it's not. But you get all these metrics out of the box for free, which is really nice because you didn't have to add that stuff. And that means that you don't have to keep pestering different teams to add these metrics into their applications, right? It kind of comes out of the box with Istio, which is really nice. And then the last and final thing, if we go to Prometheus, and this is like probably the worst way to use Prometheus, we actually get a custom metric. Remember that fib? Can you guys read that? I'm going to make it a little bigger. So that fib count that we created, counting how many times that function was called, actually turns into a custom metric in Prometheus. So we can do anything we want with. So here we can see that the first time I clicked a bunch, the number of function calls went up, and it's batched in a per second interval, right? And then we can see the one for each our backend, our front end, and our middleware. And the second time I DDoSed our system, it went up again, right? So which is really cool. You can actually see the number of times it's called, and it's about even for each service, which is what we expect, right? Because we're running all the same code. And so if we saw the blue one spike up, we know maybe something is wrong there. I don't know, I'm making things up at this point. But we can put any metric we want, and it's sent to our downstream without us having to understand that we're even talking to Prometheus. We just use OpenSenses, and OpenSenses is brokering that connection to an arbitrary downstream system like Prometheus or Stackdriver or Datadog or whatever, right? OK, so at the end of the day, this is what you all want, the links. So if you want to learn more about Istio, istio.io, opensenses.io. Everyone loves I/O. Google I/O, right? No, I'm just kidding. This talk, an older version of it, is at my website /Istio OpenSenses. I'm going to be updating everything to Istio 0.8, which should be the finalized API spec, hopefully, soon. And then the Istio deep dive is at that one, and all the code is on GitHub for both Istio and OpenSenses. Again, I'm going to be refactoring that code if you want to take a look at that in like a few weeks or so. With that, if you have any questions, I think I have like 2 minutes to answer stuff. Thank you.